Our final presentation is titled NZS 61439, What Do I Need to Know? And will be presented by ROWAN PECK. ROWAN is an independent consultant based in Canberra who works mainly in the critical systems power design and construction. ROWAN joined EL68 in the late 90s as a Consult Australia representative and has been the chair of the subcommittee for switchgear and control gear assembly since 2004. In 2005, ROWAN joined the ranks of Australian expert representatives to IEC Subcommittee 17D, which is now SC121B, and was involved in the maintenance team which developed IEC 61439 Parts 1 and 2, as well as being a leader of the working group that developed the technical report Part 0 Specifiers Guide. ROWAN received an IEC award for his contribution to IEC Technical Report 61439.0 Specifiers Guide to using this series of standards. Apart from his standards work, ROWAN is an active ski patroller at Perisher in New South Wales and a keen cyclist, kayaker, bushwalker, mountaineer and rock climber. I don't know when he has time to do anything else. Welcome ROWAN to the stage.
Left button or right button? Not that one, obviously. Okay, thanks everyone. Just to follow up on Scott's comment about device substitution, who's a Super Rugby fan in the room? Geez, not many, eh? Okay, so South Africa, New Zealand and Australia, we all have the same comment in the edition 3 of 61439 internationally about what Scott's just run through. So when the next edition comes out, everybody else in the world will understand what we do here. Doesn't make those issues any easier to deal with, but they are there. And there's a whole bunch of Scandinavian countries who want to join the team as well, which is harder to do for them in Europe. So what I'm going to talk about is how the structure works, a bit about how design verification works, the items subject to agreement and the forms of separation. Now this is a really very simplified version of 61439, and what I want you to go away with is the idea that it is actually easy to use, and there are a couple of tricks to make it easy to use and save yourselves a lot of time and energy and heartache. So some of you will be familiar with 60947, which is where all the switchgear itself is specified, and for some time that's been based on a set of general rules and a set of product standards. Okay, so what we've done with 61439 is set up the same type of structure. All right, so part 1 is general rules, and then part 2, 3, 4, etc. are the actual products. Now what that means is that if you put in your specification that you want to comply with part 1, you're going to get a box of stuff, okay, because nothing is actually built to that standard. If you want to get an assembly, you've got to use part 2, or sometimes part 3, probably for most people in the room. And I know there's a few guys from Ausgrid here, for example. Maybe part 5 will apply, and part 6 for bus bar trunking systems. You need to be careful about what you're specifying and which part you're using. The safest thing to do is probably just to say 61439 series. And the technical report part 0 is the guide to specifying assemblies. That's actually the only thing you need to read unless you're building an assembly. That's the philosophy behind it. Okay, so you don't need to pay SIA Global to go and buy all of those other bits, or you can download them for free from New Zealand, by the way. But you should get part 0 and have a good look at that. So verification is the thing that's in the standard now, all right? So we don't have type testing, we don't have partial type testing, and you shouldn't be asking for type testing. Now, if you actually look at the wording in the standard, you'll have trouble distinguishing from verification and type testing in many ways, and that's because they are in fact the same physical activity, but the terminology to use is verification, and you'll see why as I go through how this works. Okay, so talk about design verification, your specifications, your orders, you know, when you're talking to your manufacturers, because that's the language you need to be using. Oops, sorry. In 61439 part 1, Annex D has a table, and I'm going to talk through that table in a minute, but the characteristics to be verified, the clauses or sub-clauses that talk about those, and then whether you can use testing, comparison or assessment. So there's 3 different methods. Okay, testing means take it to the test station and test it. Okay, that's pretty obvious. Comparison with reference means you've got a proposed design and you're comparing it against something you have tested already. Okay, and there's a structured manner and a series of checklists and so forth to use for that. And then assessment is basically confirming that all the bits and pieces of rules are applied correctly for device selection primarily. Okay, but there are safety margins, and Scott kind of touched on the safety margin stuff. The way safety margins work is that the decision of the international group was if people aren't going to go and do tests, then they need to be because there are going to be different ways they apply those assessments. They need to put some safety margins into the assessment process so that you don't end up coming up with an assessment that gives you a more aggressive use of materials than if you actually tested it. So I'm just going to run through a very simplified version of this table, and if it's green it says yes, you can do all the characteristics. If it's orange, or whatever colour that looks like on the screen for you, it means that some but not all of the characteristics in a category can use that method, and if it's grey and crossed out, it means you can't use it at all. So there are 13 different categories, right? And there are some limitations imposed on comparison and assessment. Basically, short circuit withstand, there's an Annex P in the standard, which talks about some of the limitations that you can use there, and they're reasonable penalties against it. So the safety margins that are built into that mean that you're going to spend more money if you go down an assessment path than if you go down a testing path. And if you're only doing a one-off design, that might make sense. If you're doing 100 designs, it probably doesn't. There are current rating limits on what you can do with temperature rise, so there's limits at 630 and 1600 amps. There's quite a bit of debate about that still within the international group as to whether we should go as far as 1600. There are countries who don't want to go past 630. Australia's been pushing for 3150, so far unsuccessfully. So Max Carstead and I have that debate every time we go to a meeting, whichever one of us goes. And then I mentioned the safety margins. So they're built into these other methods of verification where relevant. So what's happening with the colour there? I don't know. Strength of materials and parts, you can do testing or you can do assessment. So I'm talking about things like bus bar supports, bits of metal casing, stuff like that, yeah? You can test it or you can assess it. Degree of protection of enclosures, you can test or assess. Clearances, you can test. You can't use comparison and you can't do assessment. Creepage distances, same situation. You can only test that. And protection against electric shock, you can test or compare with reference. So right now, in those 5, some of you are thinking, oh right, so all I need to do is ever testing and I can forget about the others. Well, actually, that's not the case, because the next couple, there's no provision for testing at all. Incorporation of devices and components is where you take manufacturer data and you know what conditions you have to operate in, and you look at the data they give you and say, well, will that work in my assembly? Okay, and you can only assess that. Internal circuits and connections, same situation, you can only assess that. Terminals for external conductors, again, you can only assess that. All right, so you're not taking something to the test station to figure these things out. You're actually doing a paperwork exercise, looking at what you've got from the manufacturer of the equipment and where you're going to put it and how you're going to use it. Dielectric properties you can test and you can assess some of it. You can't assess all of it, so you've got to use a bit of testing for dielectric. Temperature rise limits, you can do all 3, right? But there are restrictions on how you use them. So testing, a couple of weeks ago in Melbourne, I had a manufacturer who took a board to the test station, 2500 amp incoming ACB, put a couple of extra vents in it for an experiment, there for an extra day, 3150 amp rating out of the board. No problem, right? No reason why you can't do that under 61439. Okay, the label on the device does not say you cannot run it at more. What it says is, I have these characteristics I have to fit within. If you test it and it works, tick. You can sell it, okay? He wasn't actually setting out to try and find that out, but he was interested to know what the result would be. 3 more. Short circuit withstand, you've got to test or you compare with reference, okay, but only up to certain limitations. And EMC, you can test or assess. Most people would just assess it. I think it's easier. Mechanical operation, you test. So mechanical operation is you'll have to get 200 operations out of a device that's built into an assembly. So you take that to the test station and you operate it 200 times. Okay, any questions so far on that? Write them down because we're going to get to the end on those. So then this is the most important part of this conversation, right? Right now I have a specification in the marketplace and there's someone in the room who's seen it, which only uses the table out of the back of the standard to specify what I want out of the assemblies I'm looking for a job. Okay? It says, somewhere else it says I want them these colours. Okay? But this table is all I need to do to specify an assembly. So Annex BB is in part 2. I forget what the annex number is in part 1. There's an annex like this in every part, and there's also an annex in part 0 to go through it. All right. So each of these annexes basically sets out all of the items that are up to the user or the specifier to choose and inform the manufacturer. And you'll see down the bottom, if you can read it, there's a default arrangement column. If you don't nominate what you want, the manufacturer can choose whatever they think makes sense. Whether that's commercially makes sense, technically makes sense, or anything else, that's up to them. You get no say in it if you don't say anything about it. All right? So it's really important to understand what the default arrangements are, and they're all described in part 0. All right? And it's really important to understand whether you really want to change some of them, because a lot of the time you don't need to. Okay? Don't get all carried away about, hey, I need to specify a whole bunch of stuff. You can use this table, it runs to 3 or 4 pages and you've specified a whole assembly. It's based on something that's been done in France and Germany for a while in different ways, and what we've done is develop that into one table that works across the whole standard for everyone in the world who uses it. So we've got one in each table. They're grouped in categories, and I'm going to talk about the groupings and give you a little bit of insight into what's in them, but just go read the table, it's pretty simple. And they're all you need to specify an assembly. Okay, doesn't mean you can't ask for other things. So part 0 talks quite a bit about, the user might have special requirements, they can say so. There's nothing wrong with that. You can go and ask for extra stuff if you've got a legitimate use for it, but you don't actually need to. Okay, you can use this table to just do everything you need to do. So the categories are electrical system. Basically you provide a single line diagram, defines your earthing system, voltage, frequency, and any additional requirements you might have, right? How you want the thing arranged. Short circuit withstand is pretty obvious, so you've got to nominate supply KA. You can also nominate neutral and earth if you want. How you want the SCPD to work, coordination, and any loads that contribute to the fault level. So all of that goes in that category, right? So again, you don't have to nominate all of them, but you'd better tell the manufacturer the voltage, the frequency, and the short circuit rating, right? And you probably want to tell them the current rating, which is actually the last one. Protection against electric shock, you can have basic or fault protection systems. A lot of people won't ever need to worry about that. You won't need to pick anything that's a little bit different. The installation environment, so this is where you say I want this IP rating. Does everyone know what IK is, by the way? A lot of people probably won't. IK is basically kick the switchboard, hit it with a brick bat, whatever, right? That's your damage level. Very few people use that in practice. What corrosion issues you've got, ambient temperature and relative humidities, the altitude it's going to be installed at, the EMC special service conditions about maybe harmonics, things like that, right? So that's all the installation environment. The manufacturer needs to know that because they may have tested an assembly which doesn't actually meet some of the requirements you have, and they have to make adjustments to meet those. The installation method is where you're going to put it, how it's going to get there, how big it can be, how heavy it can be. Maybe you've got limitations on how you can put it into position, shipping limitations, what the external conductors and terminals and so forth look like. Okay? Storage and handling is how you get it to the site. So do you have specific requirements about shipping units, storage, the way it's packaged and so forth? Operating arrangements are what access and location requirements you have to actually operate the assembly. Okay, what isolation of loads? Some of that will be defined on your single line diagram, a lot of it won't be. Maintenance and upgrade is about how easy the assembly is to maintain and upgrade whilst in service. So I'm going to touch on forms of separation, and there was quite a lot of debate in the international group that does this standard about what is forms of separation for, and in the end it was agreed probably pushed fairly hard by myself, South Africa, and a couple of the Scandinavian countries, that it's about maintenance and upgrade. So form of separation is about how you want to maintain and upgrade and also install a switchboard, and where this what safety aspects you put into that. Okay, so all that, connections, protection during maintenance, what form of separation and so forth, and your test capability is all in there. Current carrying capability is the last one. So what's your rated current of the assembly, of groups of circuits and of circuits? Okay, phase to neutral cross section is also in there. So if you specify all of that stuff, you've basically finished specifying an assembly. So you can just take the table out of the standard and fill it in. Job done. All right, pick a colour. Here's an order, get on with it. That's as hard as it is now. All right. So please take the time to understand what's in that table and make use of it. It'll make the manufacturer's job a lot easier, and it'll make your job a lot easier if you're specifying and ordering switchboards. It also makes the job easier for some of the people in the room who I know are looking at switchboards given to them for approval, and they go, well, what is it doing about all these things? Right? It's a fantastic checklist for everybody involved. In the Australian New Zealand version, there is a supplement to table BB, which is forms of separation, because we still have insulation and housing and all of that, right? The Danes are trying to buy this office. I'm willing to sell it for a few cases of their good beer, or nothing, depending on the case. But they're really keen on this idea, because there's a lot of countries in Europe particularly who are not happy with the idea that you can just get insulation and housing and call that a form of separation, because they're thinking about how effective is that in all circumstances, which is basically the same conversation we had in Australia in the late 90s or whenever that was that we did that. Okay, so I talked about what forms of separation are for. We've still got I and H, and we've got samples to illustrate what that means, and there are a few differences that I want to highlight in forms of separation which are important to understand. Okay, so table 104 this is the Australian version, looks like that. I know you can't read any of that, right? We also have another table in the AS/NZS version which basically inverts the whole process, because we felt this made it easier for a lot of people to understand what it was we were asking for. So what we've done here is said, well, let's put the forms down the left-hand side and let's figure out what's separated from what as we go across columns. All right, so if you prefer to use that one, it's exactly the same as the other one. The international guys wouldn't go with it. They like complexity sometimes. Some of us prefer simplicity. And then we put in samples to illustrate what they actually look like, which is another thing the international guys wouldn't go for. So some of you will recognise that picture from the international standard, which talks about rated diversity factor. So what we did was we took that and said, well, guess what? That's an example of a Form 1 assembly. There are no internal separation. And then we started drawing lines all over it, and I'm not sure how easy they are to see at the back, but we've got one example of this in the AS/NZS version for every form of separation to show what it looks like when you actually build one. So what's separated from what. Okay, so that's Form 2B, and then there's the other one I picked was Form 4A. Okay, so if you look at those, it makes the whole discussion about what it means a lot easier to understand. Yeah? That's what they're there for. Just to make it simpler for people to get the right thing. Now, one of the things I want you to notice about that picture, if you can see it, top right-hand corner, there's an external conductor going out of the assembly. Okay? There's a separation barrier in that Form 4A example between the bus bar and the conductor. Okay? In 3439 and 60439 internationally, there was no requirement to separate the external conductors from anything at all. They could run through the bus bar chamber. Now, not many people did it, but it was perfectly legitimate to do it, which ultimately was not very smart, because clearly the idea of separating bus bars from a whole bunch of other stuff was not to have cables running through the bus bar zone, right? If you're worried about safety, if you're worried about how do I maintain this, how do I upgrade it, that didn't make any sense. So what we did in the international standard, which is in the AS/NZS version, is we added specific requirements to separate external conductors from bus bars, okay, which kick in at Form 3B and apply to Form 4. All right, so in Form 2, you can run the external conductors through the bus bar chamber. Perfectly allowed. Not smart, maybe, but perfectly allowed. All right, so what do you need to know? You need to know about the structure, so go away and check what you're asking for. Don't ask for part 1 because you'll just get a box of pieces. Nobody understands how to build a product to a general set of rules. All right? Understand how design verification works, that there are 3 equivalent methods that they apply differently to different categories of characteristics, and understand which ones they are. Please use the table, items subject to agreement, to specify your assemblies, to choose what you want, and to assess whether they meet the requirements you've got. And understand what the forms of separation are, and the main difference is this external conductors, which essentially creates bus bar zones, by the way. Cable zones. Okay, so what do you need to do about all this? Well, go away and read part 0 and understand what it's talking about and see what it's telling you to know and what you don't need to know, okay? And then mostly you can forget about everything else. Just don't go by part 1 to 6, 7, 8 we're up to. We're developing part 8 now. You don't need to buy any of those. Just buy part 0, read it and use the table. Understand what the forms of separation differences are. Right? NZS has a couple of other special things in it, like we still have our arcing fault, which we're still not happy with the international version of that, so we've retained our own. Other than that, it's really simple. Okay? So, questions? Someone must have some, right? Yeah. This guy at the back here, in the middle. Thanks, Leanne.
Rowan, John Manigas from Ausgrid.
Hey.
Firstly, congratulations. He's done a lot of good work on this so far, I can see.
Yeah. Thank you.
In particular, my question is going to focus on cabled assemblies. What's the impact of the new standard on cabled assemblies, whether they're intended to be as a complete unit, where people are actually assembling them as a complete unit? And the particular requirement I'm interested in is the fault level requirement. How does someone prove that their cabled assembly is going to satisfy the fault level requirements?
In practice, I don't
Yes.
know. In theory, you're talking about an assembly with no bus bars, right?
Correct.
Yeah. So in practice, I don't really know how they prove it. In theory, you take it to the test station and you show that it works. But is that going to happen? I don't know. Right? Are people going to want to do that? Unlikely. So someone is probably going to come to you and say, but AS 3008 says I can do this and this fault level and this cable's all okay. Well, yeah, maybe. But if it's being put together as an assembly, it should be verified as an assembly. So there are certain things you can verify on short circuit without testing, but you can't do all of them.
Yeah, the common characteristic of that we see in Ausgrid is that people will quote the short circuit rating of the devices themselves rather than the actual assembly, which is a bit ridiculous.
Which is not valid.
Correct.
Okay.
Yeah.
So yeah, it's not valid to take all the components and say fault level X, fault level Y, fault level Z. Yes, therefore okay. No, it doesn't work. You've actually got to verify the thing working together.
Yeah. Up to now, with the current standards, we really haven't had the ability to police that properly. But this actually looks like we actually do have some sort of.
I think the table that I went through about the methods of verification and what they apply to, yeah, you'll have the opportunity. It's a lot simpler to understand. I've got to say, the table's easy to understand. The words that go with it are horrendous to follow the logic in the standard itself. Without that table, most people wouldn't have a clue what it was talking about. But Part 0 talks through this reasonably sensibly. So, yeah.
Okay. Just on the issue of cabled assemblies where they're by necessity, where you're taking pieces of switchboard and cabling them together and that becomes an assembly. I don't know if that's been covered in the standard. Is there some way of verifying?
So if you've got one assembly and you cable it to another one,
Correct.
that piece of cable between, that's 3008 for us. Yeah. It's not treated as one assembly, it's treated as two.
Okay. Now, some people try and consider that as one switchboard.
Yeah. It's getting a bit... It's not really using the standard the way it's intended to be used, right?
Now, they're drawing a long bow to do it, but...
Yes. Yeah.
Thank you.
Other questions? Tony has a question.
I looked at the draft of the standard, and I wanted
Sorry,
to
we're
comment.
talking the Australian one or the...
The Australian standard,
Okay,
yeah, they're for the revision of the switchboard standard. And I missed the deadline. Now, I noticed not only in this particular standard, but other Australian standard, the drift towards compressed review periods and comment periods. Is there a policy in place to say, you minimise the amount of comment period allowed for people to come up with their suggestions?
At IEC level, yes.
No, at IEC, it comes
Yep.
down from the IEC, does it?
Definitely.
Okay.
Yep. Because it's been taking too long. The whole process of developing standards has been taking far too long. So IEC have set some new goals to say, this much time for comments. I think it's 2 months. It used to be 4, right? This much time to respond to those comments, etc. So yes, there is a desire in worldwide standards to bring all that down, which just means when you get the email that says comments are open, you probably should do it then.
I've had a job in which we had foreign or imported assemblies.
Mm-hmm.
One was from Austria, another one was from the US.
Mm-hmm.
The US one was something like 1600 amps with 2000 amp breaker.
Mm-hmm.
I told them it had complied with the wiring rule provisions in regards to switchboards over 800 amps.
Mm-hmm.
Now, I don't know what happened because unfortunately I couldn't complete the job because I had a gout attack and I couldn't participate in the final inspection. But what is the policy in regards to certification? I told them they had to get somebody, or the manufacturer had to get somebody to certify, possibly test it or whatever.
So AS3000 is an installation rule,
That's correct.
right? The 61439 doesn't know anything about AS3000. It's the other way around.
It's the other way around. I appreciate that,
AS3000
yeah.
now says use 61439, but you still have to do what 3000
There was
says.
a comment. There was a reference from the AS3000 to 61439 in a deemed to comply
Yep.
situation. That's in the previous
Yeah,
version
but
of the rules.
61439 knows absolutely nothing about anybody over 800 amps
Yeah.
rules about that. No idea. Not part of the story, right? 3000 sits here. 61439 is one of the standards that sits underneath. And that's a lot clearer in the 2017, 18, 19 version, whatever it ends up being, that Scott talked about, than it was before. Okay? But that's how it works, right? So 800 amps, that thing we wrote back in 1999 or whenever it was, we sat down and worked that out, right? That thing is an Australian requirement. No one internationally knows anything about it. There is I think I've put a comment into the international version, edition 3, that talks about the fact that it exists, to just alert people to the fact that there are requirements, as a number of other countries have got similar things, right? I can't remember whether it's in there or not now, but we've asked about it. So manufacturers from overseas should be aware of it, and they should be aware of at least asking the questions.
They tried to get away with a comment that it was an assembly and it didn't necessarily have to comply.
Well, it does. That's easy. That's an easy answer.
Yeah.
Go away, sell it somewhere
There
else.
were differences between,
Yeah.
for example, with the generator panel, which was an IEC design switchboard, and referred to all these compliance certificates, and the one that didn't mention is Australian. It mentioned IEC, Austrian, German, Canadian.
Yeah,
or
welcome
whatever.
to the world of international standards
And
that are
they didn't-
harmonised across
yeah.
the world, or not.
As I said, it's not my
Okay.
job to certify this.
Sorry, another question up the back?
Yeah, just wondering when AS 61439 will become enforced.
Oh, okay. So there's a changeover period, okay? So when it was published, you could use it. There is a 5-year time frame where 3439 can also be used. So 3439 is valid until 2021. So you can still provide an assembly to 3439 until 2021. After that, there is a series of tests in 61439 that are very similar to 3439. Okay, it's not all completely radically changed. So if you've done a test at the test station on 3439 and you've got an assembly that met that test, after 2021, what you'll need to do is figure out whether it meets the same test in 61439. Short circuit is essentially the same. Most of the stuff that's not temperaturised is essentially the same. The thing that's different is temperature rise, and the impact on temperature rise in 61439 is essentially that if you had a 4,000 amp board tested to 3439, it's probably going to be maybe 3,500 amps under 61439, depending on a whole lot of factors, right? But there'll be a slightly reduced current rating. Or it might be the same, but it won't be more. I wouldn't expect. Okay, so 3439 is valid now, 61439 is valid now, 3439 won't be valid after 2021, but tests done to 3439 or 1136 for that matter that meet the requirements of 61439 are still valid into the future for as long as we leave that in the Australian version. And the same thing applies overseas, by the way, 60439 to 61439, same sort of transition. Does that answer your question? Yeah? Okay, anyone else? No? Cool. You've had your go, Tony. Sorry. Okay, mate. That's me. Thanks, Ron. Cheers.
We're ahead of schedule, Scott. Do you want your other 10 minutes now, or what? Were you going to mention about...
Just one quick thing. Sorry to interrupt, Mark. Just yesterday we received notification from one of our counterparts in Victoria. The new standard 3010, which is ATS and generator connection. Is there another note for it, Rowan? It's not generator switchboards, but it's actually generator connection.
3-pole, 4-pole.
Yeah, the use of 3-pole, 4-pole, etc. That's been released yesterday. It's not one of these standards that has a time frame for its enforcement. It's basically enforced from publication. So if you're doing any work with that side of things, generators, 3-pole, 4-pole, I would urge you to have a look at it. I haven't got details of the changes at the moment, but that one's been released, and as I say, it's slightly different in terms of its enforceability. It's from its day of publishing. Okay.
Thanks, Scott. Just prior to our conclusion of today's seminar, I'd just like to thank everybody here for their attendance, and I hope that everybody goes away with some form of education today. I think I come to these things every time, obviously, and I think I learn something every time. So I hope that everybody here in the room has gained some benefit from it. I'd also like to thank New South Wales NESMA committee for their efforts in putting this event together. Also, big thanks to Leanne and Cassandra from Happenings for they're our event coordinator, and they've really brought it all together for us. Finally, we just hope we see you here at the next seminar when we have it. Thanks again.